When we think of electricity today, we think of infrastructure, the humming of a transformer or the glow of a smartphone screen. But in the early 1700s, electricity wasn't a utility, it was a ghost. To the people of that era, there were no wires and no motors. There was only the sudden, violent discharge of lightning and the strange pull of amber rubbed against wool. Scientists of the time, who often called themselves natural philosophers, viewed this force as a mysterious, invisible fluid that lived inside all matter, waiting for a reason to escape. The first step toward understanding this fluid came from Francis Hauksbee. In 1705, he designed a machine consisting of a glass globe that could be spun rapidly with a hand crank. As the globe turned, he would press his hand against the glass, using friction to strip away electrons. In the dim light of his laboratory, the vacuum inside the globe began to glow with a strange, ethereal purple light. He hadn't just created a curiosity. He had built the first friction machine, demonstrating that electricity could be generated and controlled by human hands. By the 1730s, an English dyer named Stephen Gray pushed the boundary further. He wanted to know if this electric virtue could travel. In a series of famous experiments, he suspended a young boy from the ceiling using silk strings. Gray then applied a static charge to the boy's feet and found that he could draw sparks from the boy's fingertips at the other end. This proved that electricity wasn't just a local glow. It was a flow that could move through some materials like the human body, while being stopped by others like silk. The problem with these early experiments was that the electricity was fleeting. It appeared and vanished in an instant. This changed in 1745 with the invention of the Leyden jar, named after the university where it was popularized. This device was a glass jar coated with metal foil on both the inside and outside. It acted as the world's first capacitor, a way to bottle the fluid for later use. For the first time, researchers could store a massive charge, leading to public demonstrations where hundreds of people would hold hands and feel a simultaneous, bone-rattling shock. Benjamin Franklin is often remembered for his kite, but his true contribution was theoretical. He was the one who proposed that electricity wasn't two different fluids, as many believed, but a single fluid that moved from areas of high pressure to low pressure. He coined the terms positive and negative to describe this relationship. Franklin's work moved electricity out of the realm of magic and into the realm of mathematics, suggesting that the terrifying lightning in the sky was exactly the same force as the spark on a silk string. In the late 1700s, the focus shifted from the sky to the body. Luigi Galvani, an Italian physician, noticed that the legs of a dissected frog would twitch when touched by two different metals. He believed he had discovered animal electricity, a vital life force inherent in living tissue. However, his contemporary Alessandro Volta disagreed. Volta suspected the frog was merely acting as a conductor and that the electricity was coming from the interaction of the metals themselves. This disagreement led to one of the most important inventions in human history. To prove Galvani wrong, Volta built a stack of alternating discs of silver and zinc, separated by cardboard soaked in salt water. This was the Voltaic Pile. Unlike the Leyden jar, which released all its energy in a single burst, the pile produced a steady, continuous flow of current. It was the world's first chemical battery. Suddenly, electricity wasn't a sudden spark or a terrifying bolt from the heavens. It was a reliable stream of energy that could be studied in a controlled, quiet environment. With the battery, the 19th century became an era of rapid expansion. Humphrey Davy used the massive battery bank at the Royal Institution to create the first electric light, the arc lamp. By connecting two carbon rods to his battery and bringing them close together, he created a bridge of blindingly bright light. While too intense for homes and too expensive for cities, it was a signal that the age of fire was ending. The invisible fluid was now capable of turning night into day, provided you had enough lead and acid. In 1820, a quiet observation by Hans Christian Ørsted linked two previously separate worlds. While teaching a class, he noticed that a compass needle deflected when he switched on a nearby electric current. This was the first evidence of electromagnetism. It proved that electricity didn't just move through wires, it projected an invisible influence into the space around it. This discovery meant that electricity wasn't just a way to move energy, it was a way to create physical motion, fundamentally changing our understanding of force. Michael Faraday, a self-taught lab assistant, took Ørsted's discovery to its logical conclusion. Faraday didn't think in complex equations, he thought in shapes. He visualized lines of force radiating from magnets and wires, filling the air like an invisible web. By rotating a copper disc within a magnetic field, he created the first generator. He showed that we didn't just have to find electricity in chemicals or friction. We could induce it through movement. His work provided the blueprint for every power plant in existence today. By the time Thomas Edison and Nikola Tesla arrived on the scene, the magic had already been tamed. The forgotten wizards of the 18th and 19th centuries had taken a terrifying celestial phenomenon and turned it into a measurable, predictable science. They moved us from a world of spinning glass and twitching frogs to a world of fields and currents. We often focus on who won the war of currents, but the real victory occurred much earlier when humanity first learned how to catch the lightning and keep it in a jar.
If you'd like more videos like this, you can subscribe and come back to Brief Stories anytime.